We won't give you one like that. It's on the line between quadrant 2 and 3, whatever. Yeah. Okay. So missed the first few. Sorry about that. Carry on. Draw the rotation angle in standard position. So if we just kind of did this, is this anything different? Not really. Rotation of 150. Where do we start? Right here. Always, always, always. 90, 150. That's 30 degrees before 150 or 60 degrees past 90. What way do you like to think? I don't know. Okay, there's 150 degrees. All right. Negative. Lewis? Focus. Not on the chair, on the board. Negative. What direction do we go if it's negative? The other way. We don't go this way, we go this way. Negative 210. So now you can't look here, right? That's 90. That's 180. 210 is 30 degrees past that one, so it's about like that. Okay? That's negative 210. We go clockwise, not counterclockwise from our starting position. $510. Don't worry, I know you're thinking he's going to give me like 4,050. I know it. No, I'm not. Okay? 510. Positive. Which way do we go? Counterclockwise. We start here. 180, 270, 360. How much more do I have to go? 360 and 90 is what? It's got to start with a 4. 440. Okay, how much further do you have to go? I need you want to pull out your calculator, fine, right? I need another 70 degrees. So I know I'm in this quadrant. Looks like about there. Okay, if you didn't follow that, don't worry, I'm sure you could get the answer, right? Okay, but first subtract 360 from 510 if you like, okay? And then that's another 150 degrees right back where I started, right? Just think of it as 150 degrees. Where's 150? Right there. Okay? 510. Okay. All angles with the same terminal arm are called coterminal. I just gave you an example. 510 is coterminal with 150 because they're in the same standard position. Okay, they're right on top of each other. Since 150 is the measure of this, it's the smallest one, we call that the principal angle. This isn't that important. I don't think you're going to get asked that on the test, okay? But it's nice to know. The principal angle, of course, will always be the smallest one. It's got to have some value between 0 and 360. There are infinitely many angles, right? You can just add 360 to it. One on top of the other, one on top of the other. This is more talked about in Math 12. Okay, you do quite a bit more of this. Okay, so lucky for you, don't worry about it. We're going to basically just stick with the principal angle here. Okay, I just wanted to show you that this does happen. It exists. Okay, the number gets bigger and bigger every Olympics when they're doing snowboard, right? Like when was the first tricks? There's 720s, now there's 1080s, and 13 what? I don't know, right? In a couple of years, who knows? They'll be doing like 3,000 and something, all right? Okay, point P lies on the terminal arm of angle theta. Draw it. Do you know how to put that coordinate in a Cartesian plane? 2 minus 4 There it is. Lies on the terminal arm. Well, it starts here, always positive x. And then if it's on that arm, it must look like that. There it is. Okay, don't overthink it. And it says angle theta, so let's call it angle theta. What quadrant is that in? That point? 4. -5. 2, 3, 4, -5, -1, -1. Okay, right there. There's my terminal arm. Here is angle theta. Okay. Tomorrow or the next day, we'll actually calculate what this angle is. But today, let's not worry about it. Okay, let's write the coordinates. What quadrant is that? 3, right? Okay. Reference angle, what's that? This you need to know. We'll be doing lots of this. It's the acute angle. What does acute mean? Less than 90. Formed between the terminal arm of the rotation angle, redundant, and the x-axis. Okay? Here's my terminal arm. This shows a rotation of 141 degrees. Where's the reference angle? Well, let's read it again. It has to be less than 90. It's not 141. It's the angle formed between the terminal arm and the x-axis. That is right here. Here's the x-axis. Here's the terminal arm. Okay, that's the reference angle. What is the value of that angle? This is what most of your assignment's going to be today. Okay, just getting used to the quadrants, the degrees. How do I find this value if I don't have a picture of it? Well, you know this is 180, so you can ask yourself, what do I add to 141 to get 180? It's 39. Or, what's the other way of thinking? What's 180 minus 141? It's 39. Okay? All right? Okay. Sketch the rotation angle and state the reference angle. Here's my angle, 243. Is that positive or negative? Positive. What direction do I go? I start here and I go that way. Is it bigger than 180? Yeah. Is it bigger than 270? No. So I got to backtrack a bit. 180 and how much? Where should this be? Like, make it reasonably accurate, right? 243 minus 180 is 43 and 20, 63 degrees. That's bigger than 45, so it kind of looks like that. Okay? That's 243. That's the rotation angle. What's my reference angle? My reference angle is here, between the arm and the x-axis. So what's my reference angle there? I already said it. What's 243 minus 180? 63 degrees. You're thinking of the last question, Dan. Okay, and let's write it. Reference angle, 63 degrees. Okay, you follow that? 337, where's that? There's 270, 337. I need to go 30 degrees I need to go 37 more degrees. I need to go 67 degrees. Okay, that's more than 45. That's 337. What's the definition of a reference angle? Between the x-axis and the terminal arm. Here, it's there. Okay? So it's a little bit different than this one. I'm not subtracting. What is this? Well, that's 360. That's 337. How many degrees is this? What's 360 minus 337? 20 what? $23 degrees. All right. 70 degrees. Well, that's 20 degrees away from 90. What's my reference angle here? How far is it away from the x-axis? 70 degrees. If you like memorizing, anytime it's in quadrant 1, your rotation angle is the reference angle. Okay? It's the acute angle closest to the x-axis. It's always the shortest one. Now, Jake, do you have a question? Yeah, because this is similar to the last one you asked. Well, what if it's right on the line? What's your reference angle? Does it matter which way we go here? What's your reference angle? Yeah, 90 degrees, right? Okay? On the grid, draw a reference angle of 58 degrees in all the quadrants. That means all 4 of them. Okay? So if it's in quadrant 1, there it is, 58 degrees. If it's in quadrant 2, from the x-axis, there it is, 58 degrees. If it's in quadrant 3, there it is, 58 degrees, and same thing for quadrant 4. Okay, that's the easy part. B, state the measure of the rotation angle. So, quadrant 1, that's the easy one. What's the rotation angle? How do I get from here to there? That's just 58 degrees. Quadrant 2, got a little thinking to do. How do I get from here to there? $180 minus 58 will give me this, won't it? Right? Does everyone see that? Okay. So from here to here, that's what I want to know, right? I want to know the rotation angle from here. So this thing in standard position as a reference of 58, great, but what's its rotation angle? 122. How about 3? Now it's getting a little cluttered, right? To get from there to there, how do I do that? Well, how far is it from here to here? That's 180 plus 58. Like I said, this is most of your assignment, getting used to doing this kind of stuff, okay? So what's that, 238? Okay. How about the last one? How about gray? Quadrant 4, all the way over to there. Now, if you like, you can go 270 plus this. What was this again? 90 minus 58, which was 32. What's 270 and 32? 302. What's the easier way? Yeah. This all the way to round back to where you started is 360. How about we just subtract 58 degrees from 360? That's also 302 degrees. Okay, but if you like doing it the first way, that's fine. 302 degrees. So every one of these angles has a reference angle of 58, right? They're all equivalent in that respect. Okay, we're not going to do that. This is something we want to remember, what we just did there. Okay, so the next question pretty much says the same thing. Determine the measure of the rotation angle, something between 0 and 360, given the reference angle and the quadrant. You notice they have a little sketch here to try to help us. I better get my small pen. Okay, a reference angle of 25 in quadrant 2. Do you know how to draw that? Where's quadrant 2? Right here. Reference angle, that's how far away from the x-axis. That's an acute angle. How do I get there from the starting position? What's the rotation angle? You go 180 minus 25. That's 155 degrees. Okay? That's the rotation angle. Make sense? 60 degrees in quadrant 4. 1, 2, 3, 4. That's over here. This is a reference angle. So that's from the x-axis. How do I get there from the starting position? Subtract it from 360. Yes, that's reference angle. That's the definition. It's 300 degrees. Okay? 8 degrees, quadrant 3. This is quadrant 3. 8 degrees is not very far away from that axis. I'm not even going to write 8. I won't be able to see it. What's that in standard position? From my starting point, I'm going to add that to 180, and that's 188 degrees. Okay, this is the easiest one. Quadrant 1, 39 degrees. That's my reference angle, which means that's also how I get there from the starting position, right? No, it didn't. Okay, 90 degrees, reference angle. Where's that? Right there. Quadrant. It's between 3 and 4, right? It's on the line between, whoop. Oh, hang on, that's not where I want it, right? Because I didn't answer my question. The quadrant between 3 and 4, that's down here. All right, how do I get to that position? 90, 180, 270. Okay, that's the 270 degree line from there. Last thing, determine 3 angles between 0 and 360 which have the same reference angle as a rotation of 256. A picture is worth 1,000 words. So draw it. Where's 256? 90, 180. It's not quite at 270. I want to go. That's what? I'm not thinking well. 50, 76. Okay? 76 degrees past 180. That's quite of the ways along. That's 256, right? Well, in order to get some other angles, I have three choices here that has the same reference angle as that. What do I need to know? I need to know what the reference angle for that is. Did I already figure it out? Yes, I did. Okay, from this arm to the x-axis, the acute angle is 76 degrees. So what's the easiest angle that has a reference angle of 76 degrees? In quadrant 1, 76 degrees. There's one. I need two more. That means I need all of them, right? So for this one, to have an angle of 76 degrees, how do I get from here to there? Subtract it from 180. 104 degrees will also have a reference of 76. Okay, what's the only other one I'm missing? The one down here that has a reference angle of 76. How do I determine that? Subtract it from 360. And I'm going to cheat and look 284. Okay, that's one, that's the other, that's the third, and that's all four. There's no more. Okay, 1 to 5, 7 to 18.